Welcome back to Lights Out. I'm John Weiss,
I'm Andy Henderson.
and today we're talking about teaching old dogs new tricks. No, I'm just kidding. But what we're here to talk about today is traditional manufacturers, traditional industrial companies that are using technologies to do things a little bit differently and reinvent the way they go to market, the way they do things in-house. And so just to get right into it, Andy, I have a couple questions for you. So tell me, you've been in many factories. How many of the factories that you've been into have big screens and things illustrating data throughout the facility?
Yeah, it's a good question. I don't know that I can put an exact number on it, but a lot,
A
right?
lot.
There, just about everybody has some sort of dashboard showing critical metrics like how many widgets have been produced today and what's the target for today and the week, and they're tracking those sorts of things.
In my experience, when I go through a similar experience, a lot of factories have dashboards and screens up all over the place, from when you check in to when you go all the way down to the palletizer and see stuff getting loaded on trucks, right? And everywhere in between.
Yeah.
Now, I know my answer to this question, but want to hear yours. Throughout the facility, how many of those screens are the same? How many are different?
The describe for me, what do you mean? Like what do you, the
Yeah,
same in the numbers that they're showing, or like the same in
same type of information being shown, kind of regardless of where you are.
Yeah, so in general, most of them are going to be throughput numbers, maybe some safety metrics, that sort of thing.
Yeah.
There's not a ton of variety.
Yeah, I would agree with that. And I've been in many factories, whether in the US or in Europe or South America. And the trend that I've seen is from really, regardless of where you are in the process or in the facility, the dashboards are almost identical. The same KPIs, throughput, OEE, APQ, the same stuff everywhere. Definitely safety incidents, things like that. But they seem like they're built for one person all the time. It's the same information regardless of where you go. Um, so, Andy, talking about how traditional companies are doing things in an untraditional way, I like to think of Clif Bar and Company that had an initiative to create the state-of-the-art bakeries a couple years back. And what they did was they addressed one of the things that we just talked about. It was the problem of having the same data throughout every part of the process being shown to people. Because what Cliff Bar found, I'm sure you've seen this in the field too, there were many competing interests from production and business and executives. They all wanted to see things differently. Do you agree with that?
Oh yeah, for sure. And those are always typically the folks who are driving these initiatives in the first place. So so
Absolutely.
that so it ultimately gets catered towards them.
Yep. That's
Yeah.
exactly right. And so Cliff Bar set out in they had a number of initiatives that were around creating two state-of-the-art bakeries. Pretty interesting use case, actually, Andy. One was brownfield, one was greenfield, and they did both at the same time. And so
So what do
they,
you mean by brown and greenfield? Maybe you have to explain that one.
yeah, great catch. Thank you. So greenfield being brand new facility, brand new hardware and machinery that's ready to go, ready to be connected, state-of-the-art PLCs, state-of-the-art automation systems that are virtually all plug and play, right? No retrofitting needed, versus brownfield, an existing facility, existing personnel when it comes to the change management element, right? Existing people that have done things a certain way for a long time. And the goal was to take the new factory and the pre-existing factory and make them both state of the art with new technologies. Very different
Mhm.
challenges at both. And one of the key things that they did was they implemented a strategy to break that mold of showing the same types of screens with the same KPIs throughout the whole facility. And what they did was they figured out where different personas spend the most time, or different types of people spend the most time in different areas of the facility. And then they polled the audience. They got a lot of feedback from people in those roles to determine what specifically is critical to their job and what do
But
they want to see.
that is interesting. Just for curiosity, how did they know where people were at any point in time? Were they?
I wish it was as cool as tracking people, but it's not. I think it was largely based on user or gosh, employee responsibilities. And based
Okay.
on those responsibilities and where they typically execute their function, they knew, okay, this person would typically spend time in the packaging department, or they would typically spend time near these types of machines versus these types of machines,
Yeah.
or maybe not in production at all, right? And they're back office folks.
Yeah. Tracking people does in some cases sound cool, but I think there's a lot of so that's probably the better way of actually going about it, what you're describing, because there's a lot of implications of doing it in other ways, not to mention privacy and
Oh,
there's a lot
totally
more.
agree. Totally agree. And I think probably a topic we could spend an entire show on, just talking about how people are tracking people, because there's a lot of that that's going on too.
Yeah, for
But
sure.
this was a bit, let's say, less invasive approach, if you will. And what they did was they took all of this information, and throughout the entire facility and throughout the entire production process, they started showing screens that were containing the KPIs that were important just to the people that work in that one specific area. That gave everybody at every stage of the process, from order to shipment and everywhere in between, all of the data at their fingertips to know what's happening right now. And it gave them the insight to pivot and make adjustments in the process as needed based on what the data told them.
It reminds me of a use case that I read about Cooper. I think it was Cooper Standard Automotive, I believe is the name of the company, and this was out of a Industry Week article. They were saying the similar types of things where the company was using those screens and OEE metrics throughout the operation, but there was their chief manufacturing officer was also using the utilization with information about assets and people to direct where where those assets and people should go in order to get the most productivity effectively. I'm paraphrasing, but that was the gist of what I read as well. So similar.
Definitely similar. And I think another great example of why it's so important to show relevant data to people, and it's not all the same all the time, right? What's pretty interesting about this use case too, this was one thing that was pretty easy to solve because they had a lot of the data in many ways. They just had to be creative about how they wanted to show it throughout the business. One thing that was a little bit more challenging, especially going from or tackling both a new facility and a brownfield existing facility. What they found was that the approach at building these connected smart factories were very different for both, right? The greenfield proved to be significantly easier in many respects, as you would probably expect, right? New
Yeah.
landscape, but brownfield, it proved to be pretty challenging to get the legacy equipment and systems to play nicely with some of the newer proprietary software that they use to manage their production at Clif Bar, and some of the proprietary PLC configurations and things like this that became pretty challenging to roll back into legacy automation systems. Pretty interesting concept.
Yeah. I'll say I've got direct experience in working with brownfield and greenfield sites you're exactly right. And what it ends up being at the end of the day is that you're probably just not going to get the amounts of data and the types of data out of the legacy equipment that you would get out of, say, the newer equipment. So you have to, so then that influences your strategy by saying, if I can't get that same level of information, type of information, I want to have a base set of KPI or key process indicators, key performance indicators that I'm going to use across the board for everything. But then, because I do have access to this other newer piece of equipment that provides me more data, more granular information, there are other types of there are other ways that I can analyze it now that I have these other bits of information that I can't do on the first one. So you have this difference in the level that can manifest itself as a difference in the level of performance that you get out of one versus the other, for sure.
Yep. And it impacts a lot more than just how you go about collecting the data. It impacts budget, right? Now you need new pieces of hardware, new sensors to get the same type of readings you would get from a greenfield piece of equipment that's already leveraging new sensor technology. It impacts so many things, and including the people, right? I mentioned earlier, in an existing brownfield facility, there's a big change management component that humanizes this issue, that you don't really have in a greenfield facility, because you're now hiring new employees. You don't have existing processes in place. You're starting fresh. It's a blank canvas. Versus brownfield, there's the whole human side of it, where now we're training existing employees to understand data and use problem solving and critical thinking skills differently than they would have before this kind of initiative.
Yeah. Yeah, and there's we would call that inertia, right? There's a lot of inertia in a brownfield plant versus a greenfield. There's tribal knowledge. There's the way we've always done things, and then that sometimes those can be hard to overcome. But even like you mentioned, cost of adding new hardware. That's a big consideration, because you think about those assets that you're monitoring, and where does the cost of this new equipment go? Do you add it to the value of that asset that you have on your in your plant, on your books, and what does that do to the depreciation of that asset? What is it, or and what's your replacement plan for that asset? Is it something that you expect to replace in the next 2 years? Because then you might say, gee, it's not worth adding any new piece of equipment, any new piece of data collection to it, because I'm just going to get rid of it. So there's a ton of considerations, and I participated in many of these cost modeling exercises, and the models themselves get to be very complex, trying to figure out just how much is something going to cost, and what's the best strategy for managing that cost. What do I think I'm going to get in terms of the value out of it? And can make your head hurt.
It can be very hard to calculate. And the hope is that you have some good positive outcome that is quantifiable. And in this instance, Clif Bar actually did. So one of the two factories, the Greenfield factory, actually won a year later Food Engineering's award for most sustainable factory.
That's fantastic.
So it paid off, absolutely. And that's just one example, Andy. Of course, there are so many great companies that have been around a long time that are doing a lot of really cool things. I see a lot of it in the automotive space. How about you?
Yeah, automotive is a big one. Ford and GM for sure do quite a lot. But there are examples across the board, even aerospace. Big legacy companies like Lockheed Martin that have been around and been building things for quite a while.
Yeah. You have an example?
Well, I mean, there are lots of examples. GM has done quite a few things in the space of using AI, or specifically, I know that they're working with Fanuc, the company that makes robots. Fanuc has a program called Zero DT, if I'm not mistaken, meaning zero downtime. But they were working with GM around doing predictive maintenance on these robots, and so there's it's cited in a couple of different articles where they're using vision systems to monitor the high wear components on a robot, looking for indications of things that are going to fail. And the value proposition on that is always, if you can identify something before it's going to fail, then you can take some action and prevent it from. You still have to plan for the downtime, but it doesn't come as a surprise, right? It doesn't take you off guard, shut the process down unexpectedly, and you have you know what you're going to fix before you take your action, as opposed to trying to, once things grind to a halt, now you're trying to diagnose and understand where the issues are coming from. And I think, you know, in the articles that I read, they mentioned that across 7,000 robots, GM using this, they were able to identify 72 issues before instance of failure before they led to unplanned downtimes.
Wow.
I didn't see over what time frame that was, but it doesn't really matter. That's still very cool. Very
nearly 100 unplanned downtime events prevented, right?
Yeah.
That's very significant, especially in automotive manufacturing, where you know just how costly that is. Some of these operations can cost, you know, in the thousands of dollars per minute of outage, even more in some instances. Really interesting. So if I could play it back to you, and I just want to make sure I captured that correctly. So GM has used this kind of technology to go from scheduled maintenance and reactive maintenance, where a machine actually goes down and somebody has to call in a panic because the operation has stopped, right? And the plant is shut down potentially, or the line is shut down, whatever it may be. They then evolved a little bit to get to more of a scheduled type maintenance intervals, of course, to prevent those types of outages. And now they've even taken it a step further and said, we're going to use computer vision to constantly monitor these assets and get somebody here to fix a problem before it really becomes a problem. Is that right?
Yeah, that's the gist of it.
Wow.
Exactly. And just to mention another new technology that GM is using. We talk a lot about 3D printed technology, right? It's a big thing these days, and GM has done some really cool work in 3D printing, even on the design side of things. So using a generative algorithm to let the computer design a part that's lighter weight and higher strength than the traditional one. So that's a cool story anyway. And I would advise people to go do some research if you're interested. But in terms of in manufacturing, I read a quote in an article on Manufacturing Global, where they were saying that GM was using printed parts, that they would print them and send them to suppliers for mass production. This has saved $300,000 over 24 months for their facility in Lansing. And
in just one facility.
Just one facility, exactly.
Wow.
Yeah. So that's an interesting one. You know, what I've seen firsthand for additive manufacturing or additive manufacturing inside of manufacturing are using it to produce work holding fixtures and those sorts of things that might take it might take a fair amount of engineering time and resources to design and build, whereas you can go create a prototype in a relatively short period of time before you spending all that effort and resources to do a full-on design of something. So work aids are a big use case for additive manufacturing inside of manufacturing. But then the way, and I'm taking some liberty here with this because it doesn't say specifically, but the way I interpret this article is to say that that GM is building prototypes using additive manufacturing that they can then send to their suppliers so that they have a baseline from which to build. So an example that I know of is when you're making castings. Typically, you would spend a fair amount of time designing and making the core that you would build a mold off of, and so you can use printing to do that faster with more iterations to to be able to come to your final design of cast parts of your casting molds.
Yeah,
So it's a
not to
interesting.
mention too, a lot cheaper, right?
Oh yeah, for sure.
There's there's if you look at additive manufacturing, generative design, and not to go down a bit of a rabbit hole, but it is pretty cool stuff. But it's also not just the creation of parts and molds. It's also being used by some organizations for warranty repairs and maintenance of parts. So rather than machining out an entirely new gear for a locomotive, let's just use additive manufacturing to fix the part that has chipped away, which is a massive cost savings, and of course gets the part out even quicker. Um, I
Yeah.
remember some years ago there were some efforts like this happening at GE Transportation. Don't know if it's still a focal point, to be honest, but really cool concept.
Yeah, GE was in many ways was ahead of the curve on that kind of stuff because that was a common practice was to receive the remanufacture and Caterpillar too as a big remanufacture business where you receive these used components from the field, and then there's a repair procedure that you would do on it. You might weld some new material and then machine it back down to get it back within the original specs. And in some ways, we might view that as additive manufacturing, but in the old days, we just call it repair.
Repair. Yeah.
But similar, they're similar in nature.
It was a little less automated back then, I think, but yeah.
Yeah.
So I think, Andy, we probably have time for about one more transformative use case type story, and I'd like to talk a little bit about Ford, since we're talking about automotive and GM. I think it's only fair to give a little love to Ford because they're doing a lot of cool stuff. And if you follow the technology trends, you probably have heard a little bit about some of the projects Ford is doing. They're using AI to detect wrinkles in car seats, for example, to understand inventory data, which, by the way, you might think using AI to look for wrinkles in car seats is ridiculous, but actually it's not. So
Yeah.
before this technology, they literally had every single seat went through a visual manual inspection in a factory. People
I
might not
believe it.
realize that, right? It's not a
Yeah.
magic machine that a seat goes in and it spits out a beautifully crafted leather seat or something like that, right?
Yeah, for
No,
sure. Yeah.
it's a manual process. It takes a lot of love to get it to look how you would expect it to look in the dealership, right? And so they've removed the human component from that, from having to have people manually inspect every angle of the seat, make sure the wrinkles are not there, and fix them accordingly. Now they use AI and computer vision for that. Just one example. They're also using AI for, like I mentioned, inventory data, understanding inventory levels when they need to execute POs to get more items into kitting through distribution and all of this kind of supply chain logic. And also using AI for autonomous vehicles. They have a whole autonomous vehicles division, of course. The sync infotainment system, as they call it, also relies on AI. That
Yeah.
one actually comes from Baidu. A lot of people don't know that. That's a Chinese, very, very large Chinese software manufacturer or
Yeah.
a company. So the sync uses Baidu's AI. I can't remember the name of it. And just to tell you how invested in AI specifically Ford is, they even made $1 billion investment into a company called Argo AI, which is a self-driving uh,
Mm-hmm.
technology organization. Really
Yeah.
cool stuff. Um,
Yeah, I
the
didn't realize that they were using Baidu's AI
Yep,
engine inside of their sync product. I wonder in what way
that's a
is it?
great question. I think it was related to the voice to speech
Mm-hmm.
type algorithms and things like that. Truth
Mm-hmm.
be told, I didn't know that until I did a little research either. So I don't think that's a widely known thing.
Yeah, that's interesting.
Yeah.
Um, that's something I'm going to take away and do a little more research into myself to understand it because I own a Ford. So,
Okay.
yeah.
That's
uh,
funny.
you know,
So the
the tech, sorry.
no, just going to say they're doing a lot of things around AI. But there is one part I wanted to talk about specifically that I think is really interesting, and it's the way that they have adapted computer vision to assess dents in panels through the manufacturing process. And when they're making these panels, of course, they used to produce a panel. It would go through a vigorous, manual vision test where somebody would hold the panel, they'd look at it, they would make sure there are no dents, there are no blemishes, and then they would give it the thumbs up and pass it down the line. But what they found out is that they actually had a quality issue through this manual process, because not only is there always some element of human error, we miss dents, we don't see them, things like that, but there are certain shapes of dents that the human eye actually has a very difficult time picking up, because not every dent looks like a golf ball or like a hammer hit it, right? They're all different shapes and sizes. They can be really, really small. They can be kind of big. And as quality inspectors, it can be very difficult to actually see every shape and size. And so what they did was they built this kind of crazy looking Hollywood rig. It almost reminds me of, if you will. Um, picture a pretty wide scaffolding type architecture that has lights and cameras mounted all around it, and they actually place this. It's not a fixed object; it moves, it wheels, and they wheel it right around the outside of the car. So the car stays stationary. This camera system with lighting moves all around the car, just like one of those automatic car washes. Looks at the top, the sides, and it can detect defects as small as 0.3 millimeters in diameter. Super accurate. And it helps identify all of these shapes that the human eye typically cannot see, which of course results in the beautiful Fords that you would see in the dealership today.
Yeah, absolutely. That's really cool. I have a similar experience of my own that maybe we'll get into at some point around a visual defect. It's a really interesting story. But the other thing that we haven't really talked about, the other technology that gets a lot of attention we haven't talked about is augmented reality, specifically. And there's different flavors of this, but specifically the like the heads up displays, the glasses you might wear where you can see through at at your surroundings, but it overlays information on top of it. And I actually remember reading an MIT technology review article from like 1990 something. It was talking about some work that Boeing Research was doing in manufacturing, where they were using a very early version of some glasses to for people doing wiring harnesses. And you can imagine the wiring harnesses on an airplane are I forget, but many thousands of feet long, maybe even miles. I honestly, I can't remember. But the gist of it was you had different stations, and there was a lot for a person to remember in terms of which wires, which pins, which wires go into what holes on a socket. And so there would be markers along this wiring harness where the camera would see these markers, and that would tell it where it was, and then it would put instructions showing which wire and pins go into what holes on the sockets at all these different stations along that wire. So a really practical and cool use case. And we think about it as a brand new technology, but no, that's been around for decades now. Some of the more recent and cool use cases are like at Lockheed Martin. There's a couple of articles out on the internet about how they're using it in the production of the F-35. And one of the quotes was, it's like that using it is like looking at Legos and having the instructions overlaid on top of what you're looking at. So like, if you can imagine putting together a Lego, I can imagine this because of my kids, but putting together a Lego set and having those instructions in front of your eyes for how to put it together. But imagine doing that, having that for the assembly of an aircraft, of a fighter jet. And let's see if I can, some of the numbers that were being quoted, and this was one of the article that I'm quoting here about it was from Popular Mechanics, but it says that the software that they were using with those glasses, I guess the combination of the software and glasses allows them to work 30% faster and with accuracy up to 96%. So
wow,
it's important because the higher that accuracy gets, the fewer number, the less, potential scrap or rework people generate. And those would be high cost for anybody. But I can imagine, I don't know the numbers obviously, but for a fighter jet, that could be astronomical, the cost of either of those. So being able to cut that down is truly uh, impressive.
Yeah. So as a somebody in the production process, I can put these glasses on and I get turn by turn directions, if you will, overlaid into the real world, right? In this
Yeah,
augmented reality. And it tells me exactly what to do to make sure I don't make some kind of mistake in the assembly process or something like this, right? So take the bolt from this box and put it onto this tool, and is it torqued enough, and all of these kind of turn by turn directions to make sure there's no waste or scrap, right?
absolutely. And the other thing that they quote in the article is the it, it requires less training for a person to be able to do the job consistently. So this gets back to something that you and I have talked about on a bunch of occasions, and we've even recorded some sessions about on the skills gap,
Yeah.
where um, if we can um, go bring those people into manufacturing that may not have the exact set of skills needed for the job, these types of tools can augment them, that take from their name, to be able to get them up to speed faster so that they're as productive as um, their counterparts in a short amount of time.
Yeah.
So
This
another benefit.
the skill gap is definitely real, and the skills and responsibilities and all of the things that go along with working in this business are changing, and companies are looking for different things, and employees are bringing new talents and new knowledge to the workforce. So really interesting stuff. In fact, Andy, we're going to be talking about that in our next session, but I won't steal any of that thunder. So I think we are just about out of time. To the audience, would love to hear from you. If you know about an organization that's doing some really cool things and you want to tell us about it, or you want to hear us talk about it and do some research, just let us know. Drop a comment below. We'd love to follow up with it. But Andy, my good friend, I think we're out of time. So until next time, like and
Been great.
subscribe, drop a comment, and we'll see you folks next time. Thanks so much.
See ya. Bye.